Basic science is an integral component of self-reliance. Today, the importance of science and technology is more than ever before. SMT linked to industry is central to the development of our nation. The science and technology self-reliance is seen as comprising of the development of indigenous capability in various strategic sectors like space, nuclear energy, and defense, as well as public sector industries, which are the core sectors of the economy of our country. Premier research institutions in science and technology, higher education institutes like the IITs, IISc, AIMS, and a network of various industrial research laboratories have been set up in the pursuit of self-reliance of the nation. With such objectives, the theme of today's session of Vigyan Utsav is Basic Science for Atmanirbharata. So we begin our today's program with the traditional lamp lighting. I request Dr. Narottam Sahu sir, advisor GUJCOST, to give the brief about the program.
Good morning, everybody. Respected Dr. Devapriya Datta sir, Head Scientist G, Advisor, Scientific Societal Mission and Seed Division, a State S&T Council Program, Department of Science and Technology, Government of India. Dr. Sanjeev Kumar, Professor, Physical Research Laboratory, Ahmedabad. Dr. Subrat Mukherjee, Professor and Dean, Institute of Plasma Research, Gandhinagar. Dr. Madhukant Patel, former scientist ISRO and industry mentor in automation. Professor Dr. Satadru Bhattacharya, scientific engineer SF, Space Application Center, Ahmedabad. Dr. Atul Dikshit, Associate Professor, Mathematics, Indian Institute of Science, Indian Institute of Technology, Gandhinagar. All my colleague, Dr. Poonam Bhargav, Principal Scientific Officer, GUJCOST, Dr. Payal Pandit, Scientific Officer, Research and Development, GUJCOST. All our member secretaries, Director General, Directors of State S&T Councils and the scientific members, all our CSE coordinators, the university department professors, faculties, students. It's a great honor for GUJCOST and the Department of Science and Technology, Government of Gujarat, to host the 10th edition of this Vigyan Utsav. It's a flagship program of Department of Science and Technology under its State S&T Council network, which is going in a very systematic and very innovative way all across the country. We are very happy that this month Vigyan Utsav, which has the theme like Basic Science for Atmanirbharata, Atmanirbhar Bharat, which was being hosted by our sister concern, our network member, Karnataka State S&T Council, and GUJCOST. Today, GUJCOST is hosting this program for our on the Gujarat perspectives and our activities and our perspectives. We are very much thankful to Dr. Devapriya Datta sir for his kind consent and his mentorship, guidance for all entire this program and in other activities also. So with our kind request, sir is very kind enough to spare some of its valuable thoughts to give a opening remark that how this basic science has the key or the potential initiatives for all the applied sciences and or further development. And that will be help us, all our faculties and speakers of this program, so that our discussion will be rolling on that basis. So we thanked everybody, all our faculties for their kind support, kind concern for these things, and all are Gujarat, Ahmedabad, Gandhinagar is blessed with all such very premier institutions like Space Application Center, Physical Research Laboratory, Institute of Plasma Research, Indian Institute of Technology, Gandhinagar, all these fundamental in premier institutions which are giving promotion to the fundamental science, basic science and physical sciences for the development. In fact, today is also another historical day for every Indians. Today, our Honorable Prime Minister is inaugurating this in-space program, which is giving a boost to our young entrepreneurs, and all the small and big companies, those who can play a bigger role in the very visionary missions of the Indian Space Research Organization. We can say that through this basic science, now our startup entrepreneurs, they can also start their business in the space research and space industry. So it has lots of gives the foundation to all sorts of development, Atmanirbharata, our knowledge economy, our countries, our strength, our prosperity to lead the nation as per our Honorable PM's message and campaign. So with this word, I once again express my sincere thanks and gratitude to Dr. Devapriya Datta sir for his kind consent, guidance, and all our guest faculties. And we hope that with the meaningful discussion, presentations on the perspectives of the basic science, all our faculties can inspire the young students, the teachers, the science communicators, those who are working in every district community science center level, the regional science center level, or in the school science clubs and other remote places, for which they can be the great role model for bringing that basic science as a fundamental understanding and fundamental learning for all sorts of our career and future. Thank you so much, and we wish a very meaningful session on this important topic. Thank you.
Thank you very much, sir. I now request Dr. Devapriya Datta sir, Head and Scientist of Seed Division and SSTP Division of DST Government of India, to give his opening remarks and express his insights and ideas on today's theme. Sir.
Thank you, Dr. Pandit, and thank you, Dr. Sahu, for inviting me, and also good morning to all of you, and a special, the welcome to the experts who are present on this 10th on this sessions of the basic science for Atmanirbharata. These sessions as a part of the Vigyan Utsav, which we started as a part of Azadi ki Amrit Mahotsav, in order to showcase and understand that the network strength of the state SNT councils, which was established almost 50 years before in different states. It had been established at a different time. So I first welcome Dr. Amrit Mahotsav, Professor Subrata Mukherjee, Dr. Ketan Patel, Dr. Atul Dikshit, and Dr. Shodadru Bhattacharya, and also the Mr. Hiranmay Mahanta, and my colleagues, Dr. Poonam Bhargava, Dr. Payal Pandit, and all colleagues from the state SNT councils who are present there. This, as a part of this, the Azadi ki Amrit Mahotsav, that 75th years of India's independence, we thought about to showcase the unique, the center and the state collaborations that which is the state SNT council network, which was established, as I told, in the 1971, and that how really now these state SNT councils should contribute into the evolutions of the state level STI ecosystem. And why it is important? Because the Indian science and technology, like after playing an important role into the nation building, is now itself is evolving into an enterprise. and in development of science and technology and innovation enterprise, it's important to identify the component of the STI ecosystem and to catalyze and nurture them. And there, the state S&T councils being in unique mechanisms between the center and the state science and collaborations can play the role of the nucleus in that. Now, in this state, the science, technology, and innovation ecosystem, if you look at it into the different component which we are currently working on, the core is the research and development, which leads to the knowledge as well as the technology. The technology, its utilization for the socio-economic development of a state and the nations. Then the human resource development and the infrastructure which gives the S&T organizational capacity. Then the policy, then the science and technology, the communications, which is at the end of this S&T, like an output end of the S&T in the enterprise, as well as the overall the relationship between these components. Now, this month we are focusing on the basic science, which is a component of the the R&D. The importance of the basic science, everyone like especially the students who have joined here. I think you must understand that the basic science is the the hemoglobin of this state of the S&T enterprise, what we are discussing today. Just look at it into the time of this pandemic, the way the whole world, especially the India, has responded to first understanding that the nature of the the virus itself and responding to it. It's now we have our vaccines which are available would not be possible under a strong the basic science base. Even today, what we are communicating now with this, the World Wide Web, the basic of that is in, the basic science contributions. The United Nations has, really appreciated the contributions of the basic science, and in order to strengthen its role for the sustainable development, is celebrating this year as an International Year of Basic Science. Which for mobilizing to convince the economic and the the political the sectors as well as the every citizen that our dependence on basic science for ensuring a balanced, sustainable, and the inclusive development of the planet, whether in terms of the usage of the technology or in developing the the knowledge itself, like the knowledge which are depending on that our welfare system develops. The basic science plays a huge role, and in order to attract the young generations towards the basic science, which is a challenge before that the the Indian S&T the enterprise, we need to highlight that the joy of doing science, because the science the joy of doing science, the scientists who are present here need to highlight to the next generation, so that more people they come into that the joy of doing science. Now the basic science, the way it was done, maybe the time of the Newton and the Einstein, and now what we do hasn't the significant change, because the basic science is now has to be looked into as a part of the total knowledge value chain, which provides the competitive advantage of these nations into this the globally competitive nations. If the developed nations who are in a better the socio-economic situations have the strength of the basic science, and in this context, India, especially the Gujarat and the city where you are, like in the GUJCOST, has a huge the ecosystem, because as already Dr. Sao was telling, that we have many the important science and technological institutions, like the Space Application Center is there. You have the PRD is there. There are many other the Institute of the Plasma Research is there. So there are many other the the S&T institutions are there. But at the same time, the Gujarat has the strength of the entrepreneurships. And this too should be looked as in the continuum, because that's the way the basic science was done 100 years before, and now we should not think that the basic science is a process of the knowledge generations only within the boundary of the laboratory itself. That's type of the open sky research is there, should be there, but we must know that the research, the generations of the knowledge which is a common good, how that common good can be nurtured to improve, at the same time how that common good can be converted into the economic good to bring the benefit to the majority of the the citizens. It's not only the technology which can really be accessible to a limited number of people because of the economic advantage, how the technological the pathway which can really touch the life and livelihood of the majority of the people can be strengthened to that. And I think this is the time, after the 75 years of our celebrations and understanding the role the science and technology has played in the nation building, we must develop our own model where basic science should play a role of the India's own growth story, which the benefit can be reached out to the majority of the people who couldn't, probably because of the different reasons, couldn't they be a part, take part in the mainstreaming the nation building. And this is the challenge in the coming 25 years. All of us in the scientific community, and let us remember the responsibility which has been given to us by Honorable Prime Ministers, who has said by 2047 the coming India's 25 years of the development story will be driven by the science and technology. It is not only a recognition, it's the responsibility which has been entrusted to us, and this responsibility we shouldn't we shouldn't do by only looking towards the higher level, at the global level, knowledge, the participations in the knowledge ecosystem, which is important, but how this advantage of this the basic science, the knowledge output of that, we can bring it to the socio-economic development in the majority of our country, the second largest populations in the world, and also of our democratic system. In alignment with that, we can develop that model. This is the challenge, and I think from that point of view today, I'm sure that what we are going to discuss it, we as Dr. Sahud knows, and all of our colleagues knows, that we are trying to bring out by the end of this Vigyan Utsav in August, the STI ecosystem situations and what we need to do in strengthening it from the Atmanirbharata report. So I request you please look at it into that framework, and what we discussed today, you please look it into the as-is situations in the basic science in the state, at the state level, and also find out that in the context of this Atmanirbharata at the state level, for the total knowledge value chain, what we need to do for catalyzing the basic science, so that we can really create value for the majority of the populations in the state. With this, the comments, I wish you all the best, and I'm very sure that the Council being in one of the pioneer councils within the country, you will help us in developing the unique India-centric model, which probably as our Prime Minister again talks about, that the India being the Vishwa Guru, we can share with the other the nations, and the India's the leadership for a sustainable and the peaceful nations we will be able to establish. Thank you very much.
Thank you very much, sir. Thank you for bringing out the contributions, significance, and challenges of basic science, which will lead to an Atmanirbhar Bharat. Thank you so much, sir. I now request our next speaker, Dr. Sanjeev Kumar. He is a professor at PRL Ahmedabad, and he has PhD in geology from PRL. His research interest broadly revolves around the cycling of bioavailable elements in different ecosystems. He normally employs elemental and isotopic approaches to understand the interaction among physical, chemical, and biological processes that control the distribution of these elements in the Earth system, which regulate our environment and climate. He has a number of research publications to his credit. We request you for your talk on the role of basic science for sustainable development in the Indian context. Sir.
Thank you, madam. Good morning to you all. I'll just flash my slides. Can you see my slides, please?
Yes, sir.
Is it in full view now, right?
Yes, in full view.
Okay, thank you. So, thank you very much. First of all, I would like to thank the Department of Science and Technology, Government of India, and of course, GUJCOST for inviting me for this particular topic. The topic given to me is like quite broad. I would say that the role of basic sciences in sustainable development in Indian context, but at the same time, it is very exciting. The thing is, like, how do we define sustainable development? Normally, we define it as a kind of an approach to the economic development without compromising our environment for the future generations. But to do that, first of all, we have to develop a policy framework, right? And to develop a policy framework, we have to understand the impact of these developments on our ecosystem or environment. And to understand the impact, we have to fall back on the basic sciences. And basic sciences, you would notice that it becomes indispensable. Since I work in environment and climate change, I would restrict myself within the 10 minutes to just show you some of the examples which I am working on. And particularly, I've been asked to give in the Indian context, so I would give some examples of from Gujarat or all across India. So when we talk about the development, we are normally blamed, particularly India is normally blamed for the emission of greenhouse gases, right? And but for example, it has often been said that a lot of anthropogenic nutrients or anthropogenic inputs which goes from the rivers to the ocean, our coastal ocean, emit a lot of nitrous oxide. And these being greenhouse gases are responsible for the climate change. So you might have seen in the newspaper and all those places that a lot of blame comes to country like India and China. So in that context, to just how to budget this greenhouse gases coming from the aquatic systems or soils of India to the atmosphere or because of the anthropogenic inputs, how do we do that? How do we employ the basic science to understand that? So I'm going to show you some of the examples. Let us just be very close to our home. Let us just see our Sabarmati river, right? You know the Sabarmati, we have engineered it. It starts flowing somewhere in Rajasthan and then comes to Ahmedabad, and then we have a river front in the Ahmedabad. We have a riverfront somewhere in Ahmedabad, and then if you go downstream of Ahmedabad, we have kind of a wastewater, right? And then if you look at this Mahi river, it is relatively pristine. And then in the Sabarmati again, we have pumps of water of Narmada, and we have a lot of canals. So what happens to these greenhouse gases like CO2, methane, nitrous oxide once we engineered a natural ecosystem? Now, if you look at the Sabarmati, it's something like this, right? If you have very pristine tributaries then you have kind of a pristine river. Then you have riverfront where we have blocked the river, and then of course there are kilometers and kilometers of Narmada Canal, and then downstream of Sabarmati is really polluted. And then you have rivers like Mahi, which is relatively less polluted because it doesn't have too much of urban influence. So one of my students who is working on his PhD in the rivers, he tried to quantify that what happens to these gases. How much gas comes out of these rivers or our ecosystem to the atmosphere, and how much is the dissolved concentration of these gases. So if you look at it, the one thing, this upper graph is of the carbon dioxide dissolved in these rivers and the canals, and then this one is the nitrous oxide. Now, if you look at it, I was expecting that since we have stopped the water in the riverfront, the concentration of the CO2 and nitrous oxide should be really high because it is the residence time of the water is quite high, but we did not find so much during the period which we studied. But what we found very alarming is the wastewater, the CO2 coming from the wastewater, and of course nitrous oxide coming from the wastewater. So just one example to the students who are there, that if you treat a lot of wastewater coming and there are a lot of organic matter discharged into the river system or in the lake system, then that is a process called mineralization or decomposition through which these gases are produced and goes into the atmosphere. And ultimately these gases are responsible for our global warming, or regional warming for that matter. Now let us just think about this. Like we have big rivers like Ganges, Brahmaputra, Narmada, all these rivers goes to the cities and towns. Now we have a lot of what do you say, sewage or untreated water going into the river sometimes, and then ultimately they go to the point where they meet the ocean, right? So the rivers where meet the ocean is called estuary. Now I'm giving an example from West Bengal. So this green patch which you see is what we call as Sundarbans, which is like a mangrove ecosystem. It's relatively very pristine mangrove ecosystem. Just by side of this mangrove ecosystem, there is a river called Hooghly, which passes through Kolkata. It's a metro city and a lot of urban population. Now, if we contrast these two ecosystems, this is the Hooghly, which is kind of a highly polluted, and this is Sundarban, which is relatively less polluted. Then what happens to these gases in these two ecosystems? So one of my postdocs who was working with me, Manav Datta, he did this study and he measured a lot of parameters related to carbon and nitrogen, but I'm just showing you very small part of it, that is the CO2 concentration. Now, if you look at the Hooghly, for example, the CO2 concentration is almost like 5,000 microatmosphere, whereas in Sundarban, it is almost like 10-fold lower. So just to a common man, just to show you common man or in the layman terms, what does it tell us? It simply tells us that if we pollute our environment by due to the sustainable, due to the development or due to the anthropogenic inputs, or if we don't care while developing that how to modulate these changes, then this is what is going to happen. That you will end up having a lot of carbon dioxide or nitrous oxide or methane in the regional atmosphere, which will ultimately, of course, will be circulated globally. So these two are examples which I was trying to tell you that what happens in terms of the pollution, or if we do some engineering, to our natural ecosystem. Now let us go to Cochin. Now I am sure that a lot of people have heard about Cochin backwaters, right? If you go as a visitor, you notice that it's such a beautiful place. You just you fall in love with that place actually. So green and stunning. But when I was working, one of my PhD students worked on Cochin backwaters, and when we went there, what we saw is that a lot of industries on the on the backwater side, dumping their untreated waste into these backwaters. It's a very sensitive ecosystem, let me tell you. Now there are a lot of aquaculture near the Cochin backwaters. So people grow, they have fishes here, and then they put a lot of fertilizers like nitrogen and phosphorus. And then at one time they open the gates, and all this water comes to the backwaters. Now, why I'm worried about it, like if you just, and again, another thing you might have noticed is houseboat. Everybody wants to go to the Cochin, enjoy the backwaters and the houseboats. But these houseboats, there are hundreds of them, they just dump their waste directly into this water. So if you just tow a net, for example, in the backwaters of Kerala for say 10 meters or 15 meters or maybe 100 meters, you will get something like this. And that is not what we should expect out of our water system, right? I mean, particularly such a sensitive ecosystem. So what we did is we tried to do some experiment using isotopes, elements of nitrogen isotopes or carbon isotopes, and then try to see that, let us see that what nutrient comes to this ecosystem, what is the rate at which planktons and them take these nutrients. So what we noticed is the rate at which this plankton, because of the enhanced nutrients, taking is quite high. If I give you an example why this number is high, that if you go to the open ocean, this number is somewhere here, where I'm pointing my highlighter to. So this is many-fold high compared to the backwaters. It means that if you pump a lot of nutrients like nitrogen and phosphorus into the ecosystem, you generate a lot of organic matter. Once you have a lot of organic matters coming into the water, ultimately the organic matter has to die and decompose. When they die and decompose, they consume oxygen, right? When they consume oxygen, this water becomes hypoxic. So it happens even in Gujarat. If you go to some ponds and lakes, you might have noticed that's green water, right? And I can bet that in some of these ecosystems, if you do the oxygen measurement, you will find that they are hypoxic. It means the oxygen level has gone below a certain point. But luckily for the Cochin backwaters, because it is estuary and tidal system, that seawater comes and goes again. So it's kind of a mixing takes place. The oxygen so far has not gone to alarming level, but we don't know. It may happen to some pockets in future. Now, one example I want to come to the last, this is the last example, I want to come to the soils. See, now we are in fasting, even the Prime Minister had attended this Save the Soil mission. And he is also emphasizing about the soil and fertility of the soil. We are very worried about what will happen to the fertility of soils. And so the thing is this, like when you grow a plant, we all know from the childhood that, okay, we say that during the process of photosynthesis, they take CO2, water and produce their body, right? And then we forget that apart from the CO2 and the water, they also need nutrients like nitrogen and phosphorus. So CO2 the plant can take from the atmosphere, water it can take from the soil, but nutrients has to come from the soil. And this natural production of nitrogen, these nutrients, when I say I mean nutrients means nitrogen and phosphorus, etc. So nitrogen normally in the natural ecosystems come from the degradation of these plants. So these plants are made up of the organic. Once they decompose, they give back this nitrogen to the system, and then these plants take them again. But what we are worried about is that natural way of producing this nitrogen may not be enough to sustain. So we end up putting a lot of sustain our food production. So we end up putting a lot of fertilizers into it, right? Now the problem is once we put fertilizers into these soil systems, not all of the fertilizers are being taken up by these plants. Most of them, in fact, significant part of it is being through the rainfall and through the streams, they go back to the rivers and ultimately to the coastal ocean and polluting the whole ecosystem in the process. So one study, another student of mine, Niharika Sharma, she did a study where she went to different pockets of India. For example, she went to the Himalayas, Kerala, in our own Gujarat, particularly in the Kutch region, and then Western Ghats in Goa. And then it tried to see that what is the natural nitrogen production capability of these soils. So I'm just giving here an example of run of Kutch. So here we sampled run of Kutch, then bunny grassland, then some agricultural field, and then this wetland. So if you see this graph, what this graph tells you is that in the soil, in the run of Kutch, where salinity, this is the red line is salinity, where salinity is quite high, the natural nitrogen production capability or organic matter is very less, the natural nitrogen production capability is quite low. Whereas just you go few kilometers in the agricultural lands or bunny grassland, this nitrogen production capability goes high. So what it tells you is that in an ecosystem where there is very saline or an ecosystem which is very less organic matter, this natural nitrogen production capacity goes down. So let us assume that coastal region like run of Kutch, where seawater comes again and again, right, because of the sea level rise which we are expecting, then salinity of the soil will go quite high. Then because of the salinity going high, the organic matter production may go down. And ultimately, what we found is that ultimately in the long run, if you have exacerbated seawater intrusion, then there is chances that some of the coastal region may turn into kind of a desert. So that is kind of one indirect implication of this work which we found. Now, the last thing I want to say is this, that in Kerala you have rubber plantation, right? So in this experiment, what we found is that if you replace our natural forested ecosystem with a rubber plantation, what we call as the monocropping, then again in that case also we found this nitrogen production capability through natural ways goes quite low. So in the end, what I want to say is this, that development, of course, we have to do. We have to sustain, we have to develop, and of course, grow our infrastructure. But at the same time, we can be very mindful of how we do about it, how we go about it, particularly given because we have to live in this environment and in this ecosystem. So if you might have noticed that I gave you a lot of examples, and I try to tell it in a kind of a way which is not very complicated, but believe me, doing all this science, generating all this data requires a lot of knowledge. All this data which I have showed you involves knowledge of the elements, the isotopes, particularly carbon, in which two elements which I work on extensively is carbon and nitrogen. So you have to know about the isotopes. You have to know the measurement techniques, which involves the use of mass spectrometers, etc. So to develop a knowledge of what is happening in our ecosystem or in our atmosphere or in our aquatic system or in our grasslands, we have to have a very strong background of science. When we call particularly in field like this, which is not a fundamental science like physics, chemistry, and biology, to understand this kind of a science, you have to have a knowledge, basic knowledge at least, of all these sciences. So this is my message is like, okay, let us develop, but at the same time, let us be mindful of how we are we degrading our environment? And if we have to do both simultaneously, how to go about it? So we have to develop a policy framework. To develop a policy framework, we have to understand how to go about it. So in the end, I will just say this, that this is my personal favorite actually. It's a prophecy by pre-Native American tribe, where they have said that only after the last tree has been cut down, only after the last river has been poisoned, only after the last fish has been caught, only then will you find that money cannot be eaten. Thank you very much for your attention.
Thank you very much, sir. It was indeed a very nice, crisp presentation on the role of basic science for studying the engineered ecosystem and how it can help in environment remediation. We have received very nice comments for your talk from Datta sir. He says, thanks, great, thanks Sanjeev Kumar sir to bring out the basic science behind the environmental issues succinctly. It will now be interesting to bring the scientific understanding to supplement the indigenous knowledge of the community and integrate the amelioration measures of these environmental issues in their livelihood system. So thank you so much, sir,
Thank
for
you.
your talk. Next, I request Dr. Subrato Mukherjee, sir. Sir is a professor at senior professor at Institute for Plasma Research, Gandhinagar. He is the head of LIGO India division at IPR Gandhinagar, and he is associated with GUJCOST for many of our programs. So we request for your talk on the significance of basic sciences for Atmanirbharata.
Good morning to all of you. While you may,
Yes, sir, I am loading it, sir.
so first of all, a great thank you to the GUJCOST for inviting me. And so I actually prepared one page to tell how science, as we know, probably this what I am telling is already known to all of you, and how it has progressed and we have come to where we are and why basic science is needed. This is mostly aimed not for experts but for the various centers of the GUJCOST which are distributed in the state of Gujarat, participants from there as well as students. They may take this slide and then later on contact me or other or my colleagues. The email addresses are given below, and we can see how we can move forward. Now science, we all know about this famous Einstein's equation, E equal to mc square. So people who are from a physics background would know it, as well as otherwise everybody knows this equation. And this was a remarkable development done by Einstein. And this development happened nearly about 100 years back, and he gave this equation. It was basically when quantum mechanics was just coming into picture. He introduced quantum mechanics and gave this equation. Now this happens to be the basic equation through which we have nuclear fusion, the reaction which happens in the star and we including our sun, and the stars give us all the energy in the universe as well as in fact in our solar system from the sun. But the nuclear reactors which are there in this one, we find that those nuclear reactors also they generate the energy through fission, which is a process by which all the nuclear reactors work out. Then comes Einstein's most famous contribution called as the general theory of the relativity, as we know. And the general theory of relativity essentially tells us one of the things like, one of the consequent general theory of relativity is how black holes collide. Now we all have heard about black holes. These are basically structures in space, basically end of a star, and this black hole is such massive that even the light cannot escape. Now to detect black holes, though this is a pure scientific concept given by Einstein 100 years back, we are trying along in other institutes to develop a gravitational wave detection system in Hingoli, Maharashtra. So these are things which were we never thought we would be doing such a thing for basic science within the country, but we are doing it. And this requires fundamental understanding of the science, mostly physics, and how materials behave under extreme conditions, and then also detection at very low level. There's a big science component behind it. And many of the people who are much younger, or including even me also, we are all born after this green revolution happened. So this green revolution primarily brought one thing over there, that it was, in 1960s, we had a shortage of food. It was just after the British left and the country was just going up. Then Dr. M.S. Swaminathan, he was India's, he led a program which made India self-sufficient with food, mostly in the 4 or 5 states in the northern part of the country. And he was an agricultural scientist. I had the great fortune to listen to one of his talks in PRL, and he told that his family wanted him to be a doctor, a medical doctor. And I am absolutely confident that if he would have become, he would have been a star over there also. But he decided in somewhere around 1950s and 60s that he would follow the role of an agricultural scientist. So, which is completely one could not have thought at that point of time. And then he brought the country, made self-sufficient in food, and of course others followed it. And the recent remarkable thing for me is that looking at how Indian science has actually contributed is in the development of this vaccine called as Covaxin. I don't know how many people have taken this vaccine, but I have taken Covaxin, 2 doses. And you would be surprised to know that this is not a vaccine which came from outside. This is jointly developed by scientists of National Virology Institute. It is an institute located in Pune under ICMR, and Bharat Biotech, the company which actually made and is actually responsible for the marketing of it. So these are 4 examples. Essentially, one can give many of them. And as my understanding, my major part of the work in my career went on plasma technology for societal benefit. And currently, I'm looking at the LIGO, the project, as I mentioned on the top. So science forms the base, in my understanding. I am from a physics background. So science forms the base to do anything creative and lays down the fundamental principles. And if we try to solve everything by brute force, where just imposing our technology, I don't think personally that we can solve it. We may solve one problem, but give rise to another problem. So to solve the problems, we have to attack the problem at the grassroots, that is at the lowest level. And the problems we have enormous, like we have health problem, food, clean water, sewage treatment, pollution, etc. We can go on. The previous speaker has actually mentioned extremely nicely that if we try to do one kind of a development, how the rivers get polluted and things like that. The basic understanding comes from the science behind the problem. So we have to even understand the science behind the problem and find mitigation techniques of how do we solve the problem in a holistic manner. And that can only come from science. Later on, of course, technologies will come of making it bigger, much better, much more efficient. And recently, I was very happy to see a policy which came from Department of Science and Technology. We have Dr. Datta from DST, who may be instrumental in making this policy or developing this policy. So my colleagues who are probably not aware of this, they can actually look into this one, the scientific social responsibility. We have already heard about the corporate social responsibility. But this is the first time this document tells us what, as scientists, what is our responsibility towards the society as a whole. And this defines very nicely the role scientific research organizations should play, like our R&D organizations as well as others, how we can help the society. And at my Institute for Plasma Research, the place from where I come, it is near Indira Bridge, just beside the Amul Dairy in Bhad village. We actually spend a significant amount of effort to popularize science among school and college students and teachers. We do various programs to take teachers, and it's not plasma physics only, it is beyond that. So I would like the faculties from the colleges, the students, to come to IPR to this to see. We even go to all throughout Gujarat. Recently, we have gone even to Bhubaneswar as well as to other places outside the state to showcase this. We have live models which can show how things work, various things, how it works, and how, in fact, plasmas are beneficial to society. And within Gujarat, we recently went to Kutch and we organized a program for schools and other places. And as well as we have students coming over here. So I would like that the faculties come here along with their students, mostly school and college students. And they can write to outreach@iprs.in, or they can write to me also. So this brief presentation, I only try to tell that basic science, in my understanding, is very essential to even understand the problem, the root cause of a problem, and then try to solve the problem. And we need science as well as engineering, like we require development as well as sustainability. We require everything all together, but science probably forms the base. So thank you very much for calling me as well as for your patience hearing.
Thank you very much, sir. It was indeed a very crisp presentation with very sharp examples where this basic science has played a role in nation building and definitely leading to self-reliance. Thank you very much, sir. Our next speaker is Dr. Madhukant Patel. He is the is associated with Reve Automation. He is a former scientist at ISRO and an industry mentor. He is a seasoned professional with over 4.5 decades of rich experience in designing electronics, communications, and firmware-based product development, project management, strategy planning, corporate training, as well as with various work with organizations in electronics, communication, and instrumentation, automation, robotics, etc. He has the experience of working for ISRO for more than 18 years as a scientist and engineer. And Sir is presently working as a CTO at Texan Microsystems Private Limited. He has taken up various consultancy projects as well as consultancy services, and had conducted multiple R&D experiments at ISRO. He has a number of publications to his credit. We request Sir to talk about bringing science and technology for industry.
Thank you very much, Dr. Dukur. I congratulate Dr. Gautam Sahu and his whole team and all concerned people to organize such a wonderful event and popularize the science. So, as introduced, I started my career with ISRO, and right now I am heading a company called Reve Automation with several group companies in GIDC, Gandhinagar. And we have GFKC, Greenfield Knowledge Center. So we cater the science and knowledge within our small community in JADC and some universities and colleges. So by passion, I work with students in universities and a lot of interaction with the industries. So as objective says that basic research, the economic and social development that leads to strengthening the country to build Atmanirbharata. And these words we have started listening in last few years, and it's again credit goes to government and a lot of good thinkers and people like Dr. Sahu who are behind science popularization day and night. So my analogy, not necessarily it can have a lot of data supported, but it's my own observations. And we talk of science at PRL or ISRO at IPR and sciences in universities. Other side, like we construct huge roads and buildings. And what I have learned that we spend more money on the road construction than America spends per kilometer. Our road age or our road is like broken in 1 year or 2 years, while America, their roads are good for 10 years. So the basic science not necessarily in the laboratory and in the environment and all other physics and chemistry, but in the real applications where India needs something which is cost effective and reliable, every aspect of that. But we are missing in almost all the aspects, and now things are gearing up. So I wish that it will happen soon. So the basic research mostly is happening in the government organizations and universities, few universities, and the economy, which is like controlled or rather generated by the corporates, and now with the startup, little bit, the social development means one like the mass employment, self or otherwise, and a good life support, then strengthening of like country is one like measurement is GDP, where India is really doing good, and build Atmanirbhar Bharat, producing all necessary stuff in India by Indian and with indigenous technology is my kind of an analogy. And I'm focused more on the startups because the whole country, including GUJCOST and a lot of other organizations, they focus on the startups, and to solve this, we want to become self-reliance. So with my 18 plus years of ISRO experience, 2 years with DRDO, 30 plus years with universities, 6 plus years with incubators and startups, 24 plus years with corporate, and 40 plus years of experience in mentoring children and students. So this may be lots of parallel. Overall 45 years I'm into field of professional engineering. What I've observed is that basic research, no or hardly any access of like government's research laboratories for the startup or even the university research. It's very rare that the startups are able to reach to the real root of universities' activities. I can quote example like no, I was a startup registered in PDPU, so it's there in one of the PG building, and getting any of small support from the university research department is almost impossible. Is my experience, not to criticize, but the reality. So likewise, the startups don't have access of any of the basic research. And once we talk like in GIDC, Gandhinagar, where we are situated about 500 electronic industries, hundreds of products. In the country, thousands of products we are producing. And in Gujarat, there are so many private companies and this entrepreneurial state. Hardly any product is backed by science. So we produce is reasonably poor quality, bit expensive, and not sustaining for long. So there is the issue with the current product, what we have. And startup there is much more severe. And like building Atmanirbharata is a challenge because it is good to dream, but we need to worry about the ecosystem in terms of diverting, putting effort for the basic research in all aspect of startups. So there is no knowledge money. Knowledge money into research is not at all a culture. Hardly anybody puts risk into research, and where chance of getting a product is very little. We don't have culture. It may be big companies, small companies like Infosys or maybe TCS. We don't see any product. They may be world giant corporates, but the research nearly zero, the products nearly zero. So it's all like we rising in a very good way, and that gives a lot of strength to government and people who are into planning that yes, India can really do good because we have a good GDP, good growth. But if we see the dark side of it, this China, they put huge money, and we can like surprisingly see that the companies, the private companies, they put huge money into the research, where India we put very little money, especially from the corporates. Government put money for the research is understandable, which is there everywhere in the world. But private company putting money into the research is very rare in India so far. And I believe with effort of all government and supporting departments will change this turn. But like 17% of the population and shares in the research is 2%, which is highly unbalanced. And someday we need to worry about this. And like corporate funding into research, if we see top 10, we may be like maybe below 100 if list is longer, but nowhere we have seen or Indian companies have seen that yes, the companies put money into research is almost not there. And in terms of like unicorn is good part we are seeing now that yes, those 65 is not a big number compared to other two United Nations and China, but still it is growing well. And there is a good sign of it that someday it will happen that Indian corporates will realize that they should also put money for the startups and basic research. Another very sad part is we have jobs, some n numbers, pass out huge numbers. Still there is a shortage, a huge shortage of skills. So that is another dark side of our nation. Unfortunate that the quality of education, the skills required by the startups and the industries we are miserably missing. So these are some root cause why we are failing. So this forecast says that yes, people need ICT, uh, smart cities, smart villages, all of these things are needed, and where India can really do very good. And there is a good hope that yes, in the ICT, which is a big market globally, India will be able to really contribute well in terms of their dreams, global dreams of smart education, smart all kind of smart systems. And especially, I will emphasize on one part, which is like tangible, which we call it like semiconductors and ICs and all those basic devices, we have missed. But intangible, which is soft skills, we have good strength, and that may good give leverage to the Indian startups and Indian company to really bring prosperity, a lot of good GDP and a lot of services in the India because of this intangible, which is good for India, that value and cost of tangibles are comparatively reducing against the intangible. For example, if you talk of vehicles, say car, Ambassador, Fiat, with almost zero electronics and zero IT. And after 30 years, we may have Tesla, Google kind of car where 85% cost is electronics and IT and ICT. So for 30 years, intangible was zero in the automobiles, and now it is almost 85%. So that shows that almost every sector we talk of, intangible values are increasing, where we have good strength overall India, where we don't require much of the very, very fundamental research. It's mostly software and soft skills, which are like logic and coding, which may give good value. And good part is, as I told, that values are shifting from hardware to the software. Even designing hardware is done through software, and there India has a good strength. It is not my observation. And potential research area, what we have in the country now is biotech, growing very fast. So pharma again is going very fast. Education is about to, like, India is about to go through a big revolution, and that will give good edge to the country in terms of value, IT value added into education. Industry 4.0 again is software driven revolution. Micro farming, a lot of technology, especially cloud, IoT, and all stuff. Environment science, huge scope in India and globally. Healthcare, again a big revolution going to come. Automotive already has started, and energy is a another demanding area sector. So I believe with whatever strength we have, if we focus on this, and India will definitely prosper. So thank you very much. With available time, I thought let me try to complete in a very short time, so that I give justice to Dr. Payal to track the time. Thank you so much.
Thank you so much, sir. Thank you for a nice presentation. And yes, science is very important for any industry to develop and grow, especially for in the Indian context where we are dreaming of an Atmanirbharata. So thank you for bringing out the various industries where we can take forward with the help of indigenous development of indigenous technologies. Thank you, sir. We move on to Dr.
Thank you,
Atul.
sir. No, please go ahead.
Okay, sir. So Dr. Atul Dikshit is an associate professor at discipline of mathematics at IIT Gandhinagar. He is primarily interested in special functions, analytic number theory, Q series, and theory of partitions. And he likes to work in the area of mathematics, which is developed by our own indigenous mathematician, Srinivas Ramanujan. He has a number of publications and award to his credit. We request sir to talk on exploring math, the foundation of New India. Sir. So you're muted, sir.
Yeah, thank you. Can you hear me?
Yeah.
Yeah, thank you, Dr. Pandit, for a very kind introduction. And thank you for organizing my talk in this meeting. So let me share my screen. Is my screen visible?
Yes, sir.
Should I increase the?
Yeah, I can increase slightly zoom in.
Okay, let me try doing that.
It's readable, sir. Anyways, you can.
It's okay?
Yeah. It's readable. Yeah.
Okay. Okay, so let me start with the very definition of Bharat. In Sanskrit, we have Bha, which means Gyan. I mean, it means literally Prakash, but it's a metaphor for Gyan, knowledge. And Rat means somebody who is immersed in or is in pursuit of. So Bharat is the region where its inhabitants are immersed or are in pursuit of knowledge. So that's really a unique definition that our country has in terms of how we are seekers of knowledge from times immemorial. So we all know India has had extremely rich spiritual, scientific, as well as cultural heritage since time immemorial. We all are aware of the achievements, the magnificent achievements of ancient Indian mathematicians, for example, Aryabhatta, Bhaskaracharya, Brahmagupta, etc. So I would like to just point out here that recently, with the help of generous funding by a co-founder of Infosys, namely Chris Gopalakrishnan, we have started an ambitious project at IIT Gandhinagar called History of Mathematics in India. The aim of this project is to study the works of not only those mathematicians from ancient India who were famous, but also those whose works may not be brought to light up to now. So there are a number of them. I mean, we all know about Shulva Sutras containing the Pythagoras theorem or many other things, but there are many other achievements due to Indian mathematicians, especially from Kerala School of Mathematics about 500 years back or so, which may not have brought into light. And that is one of the goals of this project, History of Mathematics in India. There are a number of people involved in this, number of students, research scholars, postdocs who are working in this field. If we move on to recent history of Indian mathematics, then one name that just stands apart from everybody else is Srinivas Ramanujan. How great was Ramanujan? So here is a quote from E.H. Neville, a mathematician from England, who was given the duty of bringing Ramanujan from India to Cambridge. I mean, we all know that G.H. Hardy made a lot of efforts to bring Ramanujan to Cambridge, and E.H. Neville was assigned that duty. So what did Neville say about Ramanujan? Neville said that Srinivas Ramanujan was a mathematician so great that his name transcends jealousies. This is really a very beautiful sentence coming from somebody. Imagine the time. It was the colonial India, and still we are seeing this particular. Is there some disturbance from my side? I mean, is there some sound that you hear, or am I audible clearly?
No, Dr. Dikshit is very clearly audible.
Oh, okay. Thank you. Yeah, so Srinivas Ramanujan is a name which transcends jealousies. So that what more can we say about the greatness of this mathematician? So let me just briefly say about what all Ramanujan has done. So here is a photograph of Ramanujan, merely 32 years of his life, but has produced mathematics which is still being understood and worked upon, and whose applications are being found in apparently unrelated fields of science. So some of the areas which Ramanujan influenced are analytic and probabilistic number theory, Q-series and theory of partitions, modular forms and mock modular forms, analysis, in particular in special functions. And there are many others. So let me just give a very simple concept in which Ramanujan made groundbreaking achievements. So it's a concept of partition of an integer. So a partition of an integer is just a way of writing an integer in terms of smaller numbers which sum up to n. So for example, if I look at how many partitions of 5 I can find. So I can write 5 as 5 itself, or I can write it as 4 plus 1, or 3 plus 2, 3 plus 1 plus 1. And note that 3 plus 1 plus 1 is same as 1 plus 3 plus 1 or 1 plus 1 plus 3. So the order doesn't matter. This is just a canonical way of writing with the largest number first and then the next largest and so on. So we see that there are 7 partitions this way. And if we assign P of n as a function which counts how many partitions n has, then P of 5 is 7. As simple as that. So note that this is an additive process. But what Ramanujan found out was a very startling multiplicative property of the partition function. So what happened was Hardy and Ramanujan, in their very famous collaboration, that they had, one of their collaborations required finding an exact formula for P of n. By the way, even though I won't be going into these details, but a concept which is as simple as counting how many partitions of n we have has in its representation as an exact formula Bessel functions coming up, then Kloosterman sums, and very abstruse objects coming into picture. But I won't go into that. So they wanted to check their formula. So what they did was they asked another English mathematician, Percy McMahon, to calculate P of n up to 200. And it's not an easy job. McMahon calculated it by hand. Why is it not an easy job? Because P of 5 is 7, right? But P of 200 is a 14-digit number. So it grows exponentially. And McMahon used this recurrence due to Euler to get this value of up to P of 200. And see, it is something which requires the previous values of the partition function at previous integers, right? So it's computationally very expensive. It took him about a month to get the table up to 200. And I should make a note here that Indian mathematician Hansraj Gupta extended the table up to P of 300. So that's another magnificent achievement. Because see, this was in the pre-computer era. So it is really commendable. So McMahon arranged the values of P of n in groups of 5. So I have shown here. So this is P of 1, P of 2, P of 3, and so on. So, and what he did was, he also had P of 0, which is 1 by convention. So after first 5 values, that is up to P of 4 equal to 5, he put a line. Then after next 5 values, that is after P of 9, he put a line, and so on. So if you look at what these numbers are, 4, 9, and 14, 19, they form an arithmetic progression. And if you look at the values of the partition function at those integers, it's 5, 30, and 135, and 490. So one thing that is very obvious is that, okay, they all are divisible by 5. So that's what Ramanujan actually proved. But it is obvious to us because this research has already been happened like about 100 years back. Otherwise, this same table that was prepared by McMahon, he was unable to find that congruence or this divisibility property. He sent it to Hardy. Hardy, also being one of the best mathematicians in history, was not able to see this multiplicative property, but Ramanujan actually found out about it. And not only that, he went ahead and saw that if you look at the arithmetic progression with 7, then 12, and so on. See, P of 7 is 15, P of 12 is 77, and so on. There you see divisibility property divisible by 7, right? So there wasn't a line before all of this, so that one could say that, okay, Ramanujan could discover it because there was a line that McMahon had arranged it in groups. And he also discovered one more, which is that P of 11 and plus 6, that is also divisible by 11. So this is a groundbreaking achievement. And so, a lot of things have happened in the past 100 years with regards to this. Not only did Ramanujan stop by finding these congruences, but he also found out what Hardy called it as the most beautiful identity of Ramanujan. And that is, he showed that the generating function of P of 5n plus 4 is a multiple of 5. And he found an explicit representation for that, from which this congruence follows trivially. Okay, one other thing of Ramanujan that I would like to mention is mock theta functions, some concept that he wrote while he was on his deathbed. It was the last letter that he wrote to Hardy, which has the mention of mock theta functions. And it was only in the early 2000s that people were able to really understand what Ramanujan was trying to say, what mock theta functions are, and what is the mathematics surrounding it. So now mock theta functions are used in black holes, in string theory, in many, many other areas of mathematics. So Freeman Dyson had made a prophecy in 1987. He had said that the mock theta functions give us tantalizing hints of a grand synthesis still to be discovered. Somehow, it should be possible to build them into a coherent group theoretical structure analogous to the structure of modular forms which Hecke built around the old theta functions of Jacobi. This remains the challenge for the future. And Dyson's prophecy was realized in about 15 years later. Here is a Dyson. Here is a photograph of Freeman Dyson, the famous physicist and also a mathematician. What does he say on Ramanujan? Whenever I am angry or depressed, I pull down the collected papers of Ramanujan from the shelf and take a quiet stroll in Ramanujan's garden. I recommend this therapy to all of you who suffer from headaches or jangled nerves. And Ramanujan's papers are not only a good therapy for headaches, they are also full of beautiful ideas which may help you to do more interesting mathematics. Here is Ramanujan's home in Kumbakonam. This is before renovation. Now it has been turned into a museum. But this was before renovation. I got a chance, it was really my fortune to get a chance to go to Kumbakonam in 2012, where there was a big conference for celebrating his 125th birth anniversary. Here is the room, and here is the window where Ramanujan used to sit and do mathematics while watching his friends play from the window. This is the very same bed where Ramanujan used to sleep. And it's really nice that all these things are preserved nicely. So one really gets a humbling feeling after seeing how somebody who was in poverty could do so much that has bewildered mathematicians since 100 years, even now. So if you read a few years back, there was an article in Notices of American Mathematical Society. The title was Srinivas Ramanujan Still Going Strong at 125. So that was written in 2012, so it was 125th birth anniversary. So the impact of Ramanujan's mathematics and his work is only increasing. So if we go to the foundation, the concept of foundation of New India, these people, Ramanujan and many other mathematicians since then, I mean, Anand Rao, and then his PhD student was K. Chandrasekharan, who set up TIFR, and then many others. They have already laid the foundation of New India, but we have a long way to go. So basic sciences will help nourish the very scientific vein of our nation. And here is one famous sentence of Carl Friedrich Gauss, the famous mathematician as well as physicist. He said that mathematics is the queen of the sciences and number theory is the queen of mathematics. I have not put the later part of the sentence because I work in number theory, but because this was the complete sentence by Gauss. So let me give an example of Institute for Basic Science in South Korea. This was recently set up, and the very aim of this institute is to create future Fields medalists from Korea, as well as celebrated mathematicians. So everybody in the world is working very hard to increase the number of celebrated mathematicians or a number of research outputs in terms of papers and everything in a very positive way, and so are we. But we need to also improve this research in basic sciences, and there are a number of ways in doing that. Here I give a few of them. So let me first say. So one could be to, first of all, to organize programs to change the basic mindset of people, not only students but also adults, that basic sciences are as important as applied sciences. There seems to be a bias towards engineering and medical, though situation is improving quite a bit. Increase funding in basic sciences. And as Dr. Madhukan Patel just said, we should have risk takers. I mean, even though some things, some projects fail, but we should have people who take risks, and that will actually eventually improve our standing. Another thing is not emulate other nations, but have our own path. Build research culture right from bachelor's programs. I mean, in many US universities, you have this research experience for undergraduates program. And that is something which is really famous. The students who go into those REUs, they really turn out to be very great mathematicians. I mean, there are many examples of them being good mathematicians, and that is because they have started very early on. This is another thing that I feel we should really have is few world-class research journals, and all of the people in the scientific community should work very hard towards creating them. I mean, having a world-class research journal really takes a lot of hard work, and India should be known by some of these journals. I mean, like if we have PNAS, Proceedings of the National Academy of Sciences in USA, I mean, or Nature, let's say, or Science journals, everybody knows the countries just by means of these journals. So India should also try hard to get some of these world-class research journals, and we should hold each and everybody in this scientific pursuit accountable as to what we are doing, what we have produced. We should have timely assessments and appraisals, and that will actually improve the research scenario. It's already going on. It's going on a positive note. India's scientific standing is ascending year by year, but these other things could also help grow further. And I'll end my talk with two quotes. The first one, due to George Washington Carver, a very famous US agriculturist, from an African-American mathematician from about 100 years back. He says, start from where you are, start with what you have, make something out of it, and never be satisfied, as in never be complacent. And the last thing is a quote by another Indo-Canadian mathematician, Professor Ram Murthy. He says, what after all is the legacy we leave behind but for the written word? Our spoken words, our personalities all disappear like a lost fragrance in the vast ocean of time. It is only the written word that survives, which is but a faint shadow of what we have thought, of what we were, and what we have learned. Yet, it is the only means by which we can transfer the torch of knowledge to the next generation, and after that to posterity. Thank you.
Thank you very much, sir. So you brought out this talk very well, because mathematics is such a subject which is usually most dreaded subject. The students consider it like a very tough one, boring. They dread, actually say, I can't take math. I cannot take, I like to study, but I don't want to do mathematics. You brought out that subject very well, from especially with the very inspiring story of Ramanujan, and showing us a very nice humble home of Ramanujan, and so it will definitely inspire the mathematicians today, where we have various access to resources like supercomputer machines are there, which can help in taking the mathematics further. So in the time of Ramanujan, when no such access to such resources, an Indian did such a wonderful job. So it is definitely a matter of pride for us, and a learning lesson for all who want to pursue basic sciences. So thank you so much, sir. Next, I request Dr. Poonam Bhargav, Principal Scientific Officer at GUJCOST, to talk about the STI policy of Gujarat, which basically encourages young minds for the Atmanirbharata. Poonam, madam.
Thank you. After the wonderful talk, and actually a very engrossing talk of all our experts, and listening to the story of Ramanujan, indeed it was very inspiring. So now I will take this opportunity to take you through the STI policy of Gujarat. This policy, the STI policy of Gujarat, is actually doing wonders and taking the state towards Atmanirbharata. So the title of the talk is Encouraging Young Minds for Atmanirbhar Bharat. This policy the STI policy was launched on 15th April 2018, and it has come a way ahead. It started with a very great vision, a very wide vision, which says that the policy is meant to make a self-reliant, innovative, healthy, and prosperous society living in a clean, green, and sustainable environment with adequate and nutritious food, clean water, and other natural resources, valuing its own and globally available knowledge base by translating science and upgrading technology for faster, inclusive, and sustainable development. So with this vision, a very wide vision and a very important vision, the policy laid down few objectives. Around 16 objectives were laid down in this policy. Some of them are to bring science and technology to the center of social, economic, and development activities, to channelize research efforts to find products and solutions, to create scientific temper and sensitivity in young students, to create STI networks for collaboration and multi-sectoral coordination, to promote entrepreneurship and rapid industrial development, to enhance patent creation and to build hub of incubators and innovators, to make the agriculture, dairy, animal husbandry, fisheries, and aquaculture sectors profit efficient. So with these objectives, there are a few more. I have mentioned here some of them. So for these few objectives, the approach of the policy is two ways. So this is another uniqueness of the policy. So, getting the basic sciences to the applied sciences, to encourage research, and to make the sectors self-sufficient, the approach of the policy is twofold. First is cross-sectoral general approach, and the second is the sector-specific approach. Now, when we talk about the general approach, it is towards enhancement of expenditure in science, technology, and innovation in special areas of societal and industrial needs, increase in the allocation of funds to enhance lab infrastructure, to increase the personnel dedicated to research and innovation, to create a friendly ecosystem which facilitates technology infrastructure, supports services, investment, and incentives. So this is the general approach, which also includes giving research support in some of the state priority areas, which includes artificial intelligence, biotechnology, polymers and special materials, nanotechnology, IoT solutions, energy storage solutions, waste treatment solution, pollution abatement, sustainable habitat, and nutrition sensitive research. So all these are some of the general approaches which are followed in this policy. And the second one is the sector specific approach, in which specific sectors were identified which will allocate a particular 1% of their budget for enhancing the basic research, such as the agriculture and horticulture. They will put in more effort in developing new varieties of seeds, to support research and innovation, to support farm mechanization and management of agricultural waste. Similarly, health sector, education sector, and the industry and the dairy development sectors. So these were the state-specific sectors which were identified for the sector-specific approach, and a general approach to enhance the STI ecosystem of the state as such. So now, once the policy is formed, let us see what outcomes we have seen till now. So one of the outcome is the research support scheme and the technology demonstration and pilot deployment schemes. So these two schemes have been implemented by GUJCOST DST to encourage applied research along with basic research, and to channelize research efforts to find products and solutions for local needs. So these are the two schemes, in which one scheme focuses on giving research grant to take the basic research one step ahead in terms of developing a product, process, or prototype. The second scheme is the technology demonstration and pilot deployment. So this scheme gives incentives to take the product to the pilot level or to deploy some innovative solutions. In both these schemes, a maximum of rupees 50 lakhs is given to the researcher or the startup. The beautiful part is that if you have a product but you do not have a qualification of a PhD, still you can apply in the technology demonstration and pilot deployment schemes. The only thing is that you should have an innovative solution or a product which is useful for the society. Through this policy, we are also aiming to develop world-class and shared R&D infrastructure. Under this, interdisciplinary research in frontier areas of S&T has been set up as a Vikram Sarabhai chair, and under this chair, the students can avail fellowships or to have exposure to the foreign research culture and to bring that into India. 18 design labs have been established in various colleges where this is a research infrastructure where the young students, they will create some ideas and they will transform their ideas into some tangible forms. They can see their ideas working. If someone wants to see some automated wheelchair, well, they have the equipments there. They can put their idea and get the innovation done, and they can see that how small things are made in these design labs. We are also in collaboration with Commissioner of Higher Education. Innovation labs have been set up in arts, commerce, and science colleges. Now, again, this is in line with the government policies where we are promoting local youths to work on local problems and to explore more on local language at the interface of science, technology, and innovation. So in this around more than 500 colleges have been given some kits, some innovation, some kits and tools. They are also given trainings, and it's not like that it's just in the science colleges. Even the arts and commerce students are also given a glimpse where they can also have some ideas, and then they can see how those ideas are basically implemented using the STEM knowledge, the technology. We are also, Gujarat has now 26 supercomputer labs in engineering and R&D labs. And with this number, actually Gujarat is the largest, highest user of supercomputer in the country. So continuously this research infrastructure is being given, the training is being given to utilize this supercomputer in the best possible manner, and to give wings to the researchers' ideas where computation facility is provided at their own place, so that they are not like with the increase in the big data, they may feel that we do not have the computational power. But with these 26 supercomputer labs, they can actually do more research with the data that they generate. The policy is also strengthening the infrastructure for development of scientific temper and STEM outreach. This is one of the most important things which is coming out of this policy. Under this, 4 regional science centers have been developed at Rajkot, Bhuj, Bhavnagar, and Patan, and other 4 are on the way. They will soon be materialized. So these centers are actually hub of science learning. So the main aim is actually to take science to the masses without giving them like, it is not like that they have to move a lot of distance to see science, to feel science. So these centers are for seeing science, for feeling science, for and these are not centers where you cannot touch the things. Most of the exhibits and activities which are there, they are all interactive, and they are all giving an idea of how things work, the science in daily life. Each center has several galleries which give ideas on which are different in each of the centers, and also on the Nobel Prize gallery in physics, mathematics, medicine, and chemistry. These are also there to promote basic sciences, to promote knowledge of basic sciences, to promote how basic sciences also lead to a Nobel Prize winning discovery, which is in turn helpful, which in turn becomes helpful for social problems, societal problems. So this is RSC Patan, that is Regional Science Center Patan, which is now open for public, and I invite each and everyone present here to please visit the center. Regional Science Center Rajkot will soon be open, and similarly Regional Science Center Bhavnagar, of scenic beauty actually. You can see here the landscape, the calmness, and the science inside this particular center is actually amazing. Regional Science Center Bhuj is being developed on a hilltop. Again, a very different view, and this will also have a big telescope, an outdoor observatory. Apart from this, getting science to the masses also involves science at each and every level. So at GUJCOST we have 33 community science centers which are at each and every district, and these are actually hubs of science communication to the last man standing. The policy also aims towards early identification and nurturing of talent, which includes RoboFest Gujarat. It is again a very unique competition which is held every year, and beautiful robots, indigenous robots come up from students even from the polytechnic. And this competition is held at 3 levels, where the ideation stage, the prototype stage, and the ideation stage, the prototype stage, and the final stage where the prototype is actually displayed. So and at each stage a particular prize money is given, so that they can develop their idea into a very professional robotic prototype. Another program to nurture the talent and to identify a pool of talented students was the Gujarat STEM quiz. This quiz was participated by 5,39,970 students of class 9 to 12. It was a very big event across the state, and we could identify 410 district level toppers. Each from each district and municipal corporation. We identified 10 students, and of these, top 16 took to the final quiz. So the prizes were worth rupees 1 crore. Sorry, the number is wrong here. And this was live telecast, and the episodes were also live on the DD Girnar. Now, this quiz, we have not left the students behind. So the 410 students which have been identified are being nurtured further into basic sciences and giving exposure to as many national level institutes as possible. So currently we are undertaking a boot camp for these STEM students, the 410 students at the National Forensic Science University. And they are being also given exposure to SAC ISRO. They are given the ideas of various, artificial intelligence, forensic sciences, the cyber security, and so on. We are also taking the top 16 to Bhabha Atomic Research Center. Again, these students are being exposed to, experts. They are being given knowledge so that they can inculcate they can know about what the sciences can do, what future they have in these particular fields, and they can actually take up even basic sciences, or they can move further in other fields as well. Another STI Summer Camp 2022 will be held soon, and this is again a process where we are trying to inculcate basic sciences inculcate a culture of research in our state, and we are taking them to a training. It will be a residential program where the selected research scholars will be given exposure to how to write a research proposals, how the various schemes of the government which are going on. And we are also going to host the National Children's Science Congress at Gujarat Science City sometimes in November or December. And the theme is understanding ecosystem for health and well-being. And again, this is something where the students are captured, are not captured actually, but are identified young, and they are given exposure to various processes, the way to do research, the way to carry out the research, the basic research methodologies are actually promoted with this particular program. In all, our STI policy has actually accelerated the overall innovation culture of the state. It has helped in creating systems and mechanisms for increasing the engagement of students, women and youth into STI in order to promote R&D and entrepreneurship. It has enhanced the research infrastructure. It has helped in tapping and nurturing the talent at the young age. And it has also created infrastructure to reach out to the masses to spread STEM education. So with this, thank you so much for giving me this opportunity to speak on the STI policy of Vigyan. Thank you.
Thank you, ma'am, for showcasing various initiatives under the STI policy. And yes, rightly said, we invite everyone to visit our regional science centers that are a hub of science dissemination and various interesting outreach activities. The exhibits have been curated so well that even after visiting once, you would like to come again to have a feel of the same experiments. And along with that, there are various activities like the virtual reality zones and 5D theater and other activities. So we invite one and all to visit our regional science centers. So moving on, we have our next speaker, Dr. Satadru Bhattacharya. He is a scientist, engineer SF at the Planetary Sciences Division at Space Applications Center, SAC ISRO. He was the principal investigator of the Chandrayaan-2 Imaging Infrared Spectrometer IIRS instrument. He is the national coordinator for the Mars Orbiter mission, announcement of opportunity program of ISRO. His research interest lies in lunar geology, reflectance spectroscopy of minerals and rocks, study of terrestrial analogs to Moon and Mars, hyperspectral remote sensing, mineral exploration, etc. We request Sir to talk on the initiatives in space science for Atmanirbharata.
Good afternoon, Dr. Pandit. Am I audible?
Yes, sir, you're audible and your slide is also visible.
Okay, thank you, thank you. So, at the very outset, let me thank Gujarat Council of Science and Technology for providing me this opportunity to listen to the stalwarts of various fields, and at the same time to share my personal experience of working at Space Application Center ISRO. And my topic is initiatives on space sciences for Atmanirbharata. And let me begin with the things that since we belong to Space Application Center, the primary responsibility of Space Application Center is developing transponders for communications satellites, and also for navigation and navigation related activities. And other than that, we have a huge presence in the field of Earth observations and planetary science programs, for which Space Application Center is developing various sensors or the cameras or payloads. So the basic idea is, as the name of the center itself suggests, that it is about the application of various space science and technology for the benefit of society and for the benefit of the common man. And that was precisely the vision of Dr. Vikram Sarabhai, the father of the Indian space program. So as you can see in this particular slide, we are working on land processes, ocean processes, atmosphere, and then planetary sciences. So if we categorize land, ocean, and atmosphere together, we would like to say that it is all about the Earth system science. And before I start and talk a few things about all these topics enlisted here, I must say that I firmly believe, and as our previous speakers are also stressing upon the fact that without a sound platform in basic sciences, a country cannot progress. Okay, so whatever we are doing, even though it is, you may say that this is a bit of application related oriented science, or it's technological applications basically, but until unless we have a very sound infrastructure in terms of basic science and basic research, we won't be able to progress much. So that is the fact for any countries for that matter. So we are working as a planetary geologist. I'll be talking about mostly towards the application part of it. So we work on agriculture and crops, environments and forests, water resources and snow and glaciers, geology, mineral explorations, and geoarchaeology, which is a very evolving topic these days. Then we also work here on rural and urban developments, urban city planning, 3D mapping, virtual reality, all those domains. Apart from this, we have a very strong presence in weather forecasting, short-term, medium, long-term weather forecasting. And then cyclone predictions, cyclone path tracking, cyclogenesis, and then disaster management, with special reference to, I would like to say that since we are situated in Gujarat and we had this famous earthquake, so we are working on SAR interferometry based crustal deformation modeling, which is also, and towards the earthquake precursor studies. So these are extremely crucial studies that Space Application Center is involved in towards disaster management and its assessment related studies. Then, of course, global change modeling, atmosphere and meteorological studies, and finally, planetary sciences. So let me start with the agriculture and water resources. So we have some short-term goals up to 2025, and then medium and long-term goals. That's what we are basically doing. So one of the important aspect is that crop inventory. So we used to provide around for 15 to 25 crops at district and state level and national scales. And this particular activity involves different scales of data. So we use regional scale data sets like AUIFs, and then we go down to very high spatial resolution data sets of the order of ResourceSat and the least kind of data sets which are having meter scale spatial resolutions. So using this kind of multi spatial resolution data sets, and also with a very good temporal accuracy of the data, temporal revisit interval, one can generate a very good crop inventory. It is also used for crop forecasting and crop insurance studies. These are very and extremely important for particularly crop insurance kind of studies are very much helpful for the farmers basically. So other than that, we have this crop agro meteorological advisory boards, where also this kind of remote sensing based analysis, there are different products like NDVI products, crop yield products. They are being disseminated through different platforms like Mosaic, Vedas, and all other platforms to various agriculture ministry and various other ministries, and that is being regularly used by farmers for their efficient usage of their lands. for showing different kind of crops and other things. Another important aspect is this that we are going from remote sensing to, I would say that there is a paradigm shift to remote measurement. So what has happened in recent past is that from multispectral, there are now very high-end systems available, which are called hyperspectral systems, where you can really categorize or differentiate between different kind of crop species, or based on their chemistry, biogeochemistry, based on the spectral signatures or the reflectance spectral signatures that is being recorded by different kind of sensors. The sensor may be placed at a orbit, or it may be also placed at a airborne platform, or maybe even in a drone. So using this kind of hyperspectral data sets, if we analyze, we can go for precision farming, and that can also be helped us in monitoring the condition or the health of the crop. So we used to call the pest and disease related studies in crops. So all those things can be possible now with at different levels at which we were interested to look into. So you may be at a field level, or maybe cadastral level, district level, and then state level and national level. So here different kinds of satellite image related informations and their analysis, like NDVI products and ET products, evapotranspiration related products, they are extremely helpful in delineating all those kind of important informations, and they are being disseminated through various platforms. Next important application is atmosphere and ocean science applications, and the major goals is to have a weather modeling at different scales. Again, scale is always very important, and here when we are talking about the scales, it is not only the spatial scales but also the temporal scales. So now suppose we can provide a particular weather product every half hourly, or maybe in a day wise, or maybe month wise, and then year wise also. So this kind of temporal variability is extremely important to understand the oceanic and atmospheric processes. So we have this short-term forecasting, then long-term forecastings, and various models and data are being assimilated into various models. And where if we talk about the technology, we use this radiative transfer simulations, and then of course these days we are using AI-based retrieval methods, and which has improved the accuracies of this forecasting in a great way. And for sensors, we are using basically INSAT 3D, 3R, then Earth observation satellite 6, GPS, or all those satellites are being data sets coming from these satellites are being day in day out analyzed, and different operational products are being generated. For ocean applications also, if you see, one major application is the potential fisheries zone, and retrieval of geophysical parameters from OceanSat and other satellite data sets, and monitoring of the ocean color based on which you can estimate the primary productivity, and also utilizing the sea surface temperature informations and primary productivity, you can basically pinpoint the locales where the phytoplanktons or zooplanktons densities are quite high, where these are acting where fishes used to feed on all these phytoplanktons and zooplanktons. So by delineating these prospective zones, basically there is an increase of 30 to 40% of fish catch through this kind of satellite-based observations. And also we provide mobile services to the fishermen, where with GPS locations, lat-long locations, where can they find the better amount of densely populated territories for different kind of fishes like tuna and mackerels and other things. So other than that, also we have this for as a renewable energy sources. We are working on the tidal to tap the tidal energy studies, and then solar calculators are being proposed, and then also we are using these wind generated energies related studies we are doing through scattermeters, altimeters related data sets, and various models are being, data sets, these satellite derived data sets are getting into the parameters, input parameters in various models for this kind of forecastings. Another important aspect is the geoscience and environmental applications, and the goal is to understand the tectonic and non-tectonic crustal deformation processes, mineral explorations, and land degradations. They are extremely important for a short-term related. If you see the short-term goals, then under long-term goals we have this seismic hazard assessment, landslide movements or land subsidence because of the excessive pumping and the aquifer systems, and monitoring the aquifer systems as I'm mentioning. And then for long-term goals, we have this geohazard monitoring and rapid response, quantification of groundwater loss, and they are extremely crucial. And various satellite-based techniques are going to help us. Our scientists here in the Space Applications Center are analyzing them. These are the persistent scatter interferometric synthetic aperture radar based analysis, which are helping us in generating or monitoring the crustal deformations at centimeter scale accuracy or millimeter scale accuracy, and you can really understand where the strains are accumulating more or less, and which are the locales where there is a chance probability of having a future earthquake, and what could be the magnitude of that earthquake. So these are all extremely important informations from preparedness point of view. And even our communication satellites are of great help in providing important services immediately after some hazardous event has happened. So, for example, this Uttarkashi event has happened recently, that glacial outburst. So all these studies are directly related either with the analysis of scientific understanding or academic purpose, but most of them are really directly related to the societal applications for geoscience and crustal deformation studies. And then we have certain missions also coming up, like NASA, ISRO synthetic aperture radar missions to dedicatedly understand the processes, crustal deformation processes, then glacier retreat, and then isostatic readjustments, all those kind of studies. Next is the environmental applications. Remote sensing data is extremely handy in understanding the hotspots or the sensitive areas where the greenhouse gases are being accumulated, and pollutant gases, how they are behaving, and monitoring of the mangroves, coral reefs, and air quality. So all these are extremely important for our day-to-day life. And already our speakers have talked about the sustainable developments. So monitoring this kind of parameters, these parameters are extremely important for, first of all, mitigating them, and also to have a check on some harmful chemicals or pollutants. So that also we are doing, and other than that, we study space-based altimeter data for the inland water level studies, lake or other water bodies. We are continuously studying them. Then eutrophication related problems, carbon nitrogen fixations, and eutrophication related problems are also being studied through various kinds of hyperspectral and multispectral datasets. Last but not the least, ISRO has a very strong roadmap as far as outer space and planetary science exploration and applications are concerned. And as many of you are well aware of the very successful Chandrayaan-1 mission, which paved the way for Mars orbiter mission, followed by presently the Chandrayaan-2 is going on. And AstroSat is an extremely successful mission, and where we should be extremely proud of that. And many important discoveries are coming every now and then from AstroSat datasets. Here, we'd like to highlight that we are not only analyzing the data, but we have already developed a self-reliance in terms of building various kind of instruments. I'll just give you a glimpse of that. So these are the Chandrayaan-1 spacecraft. We had 6 payloads, Indian payloads, And to name this terrain mapping camera, which is generating 3D digital elevation model of the lunar surface at very high resolution of 5 meter. Then we had a hyperspectral imager, which is a hyperspectral instrument in VNIR region to map the mineralogy. We had moon impact probe also, which directly crash landed in the south pole region of the moon. So there are around 6 instruments. Then Chase 2 was there on board moon impact probe to measure the exospheric water content. So then we had this Mars orbiter missions where Mars color camera, thermal imaging infrared spectrometer, and methane sensor for Mars. So these 3 instruments were built at Space Application Center. Other than that, we had MENCA, Mars's exospheric neutral composition analyzer, and Lyman alpha photometer, which was developed by LIOS in Bangalore. Presently, Chandrayaan-2 is orbiter is operating and is providing extremely crucial data sets on the lunar surface, like orbiter high resolution camera. This is the highest ever resolution achieved as of now over the lunar surface, and it goes to around 25 to 30 centimeter. So even NASA or ESA, they don't have that much high resolution data sets. Then imaging infrared spectrometer. Again, this is indigenously developed and developed at Space Application Center with a completely indigenous design, and gratings and complete optical design is indigenous. And this particular spectrometer is an advanced version of InCube, which was built by JPL and Prono in Chandrayaan-1. And this is for generating a very high spectral and spatial resolution data sets over the lunar surface for mineralogical and lunar water mapping. Then another extremely crucial instrument is the dual frequency synthetic aperture radar. And for the first time ever, we are coming up with this dual frequency SAR instrument where we have S band and L band observations, and that too in full polarimetric mode. So one can derive the complete scattering matrix from these data sets. And L band SAR is flown for the first time ever in the history of the lunar science. So they are the real game changers, and very beautiful data sets are already being obtained, and many of them are already published. Terrain mapping camera is another crucial instrument, which is again almost the same instrument, which is a bit miniaturized, and it is again providing the 3D spatial context information of the lunar surface. So these are the various payloads I was talking about. Like this is the TMC, which is having a 4-apt and nadir camera, and then it generates through the principle of stereoscopy. It generates a digital elevation model of the lunar surface. Then we have hyperspectral imager, which is basically a wedge filter based diffraction technique is used here, and it operates in around 900 to 400 to 900 nanometer region. Then we had Mars orbiter mission thermal imaging infrared spectrometer in the domain of 8 to 14 micrometer. Then methane sensor for Mars, which was another interesting instrument which were flown for the first time on Mars to detect the presence of methane. Then we also have this imaging infrared spectrometer, which I was talking about. This is the large telescope of the orbiter high resolution camera, generating a very high spatial resolution data sets. And this is the dual frequency SAR. And if we go back and if we start looking at the results, dual frequency SAR is helping us in pinpointing where in the lunar poles you can expect the presence of water ice. And this water ice that will be used for fuel for deep space explorations. So in that, our imaging infrared spectrometer data is able to provide very high spatial resolution data of the complete water feature around 3000 nanometer. And this particular region, if we see, we'll be able to characterize completely the water feature, which was not possible in Chandrayaan-1 data. And therefore, precise quantitative analysis of the amount of water and the nature of the water, whether it is OH or H2O or H2Is, would be possible from this kind of analysis. And very good data sets are being coming, and also these are being processed. Another interesting study I would like to highlight is that Space Application Center is also studying planetary analogs and astrobiological investigations we are involved in. And in these figures, what you are seeing is that this is a hot spring basically, and these hot springs, terrestrial hot springs, are thought to be the regions or locales where the first form of life ever evolved on Earth. Okay, so this is one such terrestrial hot springs. You can see this temperature is 76 degrees Celsius. It is still boiling because we were at a very high altitude, around 15,000 feet height at Ladakh. And you can see the microbial mats developed over this. And this particular experience, when we are conducting these experiments, we are having in situ spectrometer, and we were analyzing different kind of mineral phases over these hot spring regimes. And this also allows us to understand how the different branches of science are getting converged into particularly addressing one particular aspect. So here is such a classic example where you need the expertise of biology, microbiology, you need the expertise of remote sensing, quantum mechanics, everything comes into the picture, mathematics, to address certain issues. And here the question, the most important crucial question, is that how the life first evolved on Earth. And by analyzing this kind of areas or territories, hot spring sites, if we can find a similar set of typical mineral assemblages, these study areas are quite unique in the sense that they develop a certain kind of mineral assemblages. Okay, so if we can find this kind of similar kind of mineral assemblages on Mars or any other planetary systems, then we can say for sure that these are the most potential areas where we can have a lander or rover based detailed explorations, because they are supposed to have highest potential of having preservations of the biosignatures, or if at all any kind of extent life is there on other planetary bodies or not. So this is extremely crucial. And then since we are in Gujarat, and Kutch is a geological paradise, I must say, and we worked in Kutch extensively, and Matanumad is one of such place which is now globally accepted, globally recognized Martian analog site, where we reported for the first time the presence of a mineral called jarosite. Jarosite is an iron-bearing hydrosulfate which is having an astrobiological significance. And as you can see here in this 36th International Geological Congress recently held in Delhi, this Matanumad and the nearby Kutch areas were selected as one of the field trip, post-symposium field trip site. And this particular area has already been globally recognized as a Martian analog. Now, I would like to talk about the public outreach, which is extremely important, particularly for the school kids and graduate and undergraduate and postgraduate students and researchers. We have a program called TREES. The full form is here: Training and Research in Earth Ecosystems. And we welcome students from every corner of our country. They can come and they can join us and have a hands-on on different kind of data and as per their backgrounds. So this is a very strong presence of there as far as the public outreach goes from our side, and we handle this kind of different backgrounds. So we work on agriculture and land monitoring, crop area estimation and production forecast, agricultural drought assessments, horticulture, cropping systems, and so on and so forth. But it is not limited to this. And then inland fisheries, then planetary sciences. So particularly for the students, I would encourage that they can always go through this site. The site is also here, we have mentioned it, so they can look into further. And as per their interests, and they can always write to us. So I would like to thank once again Gujarat Council of Science and Technology, and I will stop here. Thanks very much for this opportunity.
Cameras for a group photo. Please turn on your cameras, please. Thank you everyone. So I would like to present the vote of thanks for this program as we conclude our today's session. So, very rightly said by Datta sir, basic science is the hemoglobin of the whole SMT enterprise. So, thank you, sir. Thank you for joining us in this session and inspiring us for the sessions as well as guiding first for the programs as well as other activities. So definitely we will take up your comments that science and entrepreneurship should be looked into continuum. And this was a really very nice input from your end. Thank you, sir. I thank Dr. Sanjeev Kumar from PRL, and very rightly said by you that basic understanding comes from the science behind the problem. So indeed, it was very nice listening to you on the role of basic science for sustainable development in the Indian context. I thank Subrato Mukherjee sir for his very nice examples on uh, building where basic science has played a role for becoming self-reliant India. So yeah, I thank Madhukant Patel sir for his talk and definitely for building Atmanirbharata. It is necessary that we produce this stuff in India by Indian using Indian technologies. So definitely it is it has become very imperative now to for science for to learn basic science for any industry to develop and grow to achieve the mission of Atmanirbhar Bharat. I thank Dr. Atul Dikshit sir for his talk, and really it was very interesting to hear about Ramanujan's history, so ahead of his time, and we got a very nice flavor of his life and work. And really, mathematics is very useful for basic scientific research. So it's a tool. Basically, usually it is called the language of mathematics is the language of physics. So there are many such quotations that come up. So really, it was nice listening to you. I thank Poonam Madam for bringing out the STI policy and the various showcasing various initiatives under this STI policy. I thank Dr. Bhattacharya for his talk on various applications of space science in various aspects of our ecosystem. And definitely, without a sound platform of basic science, a country cannot progress. So that is the gist that we take forward for pursuing basic science. So thank you, one and all. And I request all to raise for the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल गंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे.
Thank you, everyone. And we close this program here.